Hey everyone, I'm Aftab Hussain. I'm from IIT Hyderabad, and I'll be presenting smart street lighting solutions using Bison as a protocol. So in IIIT, actually, we have a very interesting sort of a lab, what we call the Living Lab. It's specifically dedicated to smart cities because the session is smart cities, right? So I wanted to talk about this lab for a bit before we get into the technicalities. This particular lab has what we have done is we have basically converted the entire IIIT Hyderabad campus into a microcosm of a smart city by putting up all of these sensors and actuators at various locations. We have like 300 sensors all connected to a middleware where all of the information is stored, and from there we do all the analytics on it. The entire stack for that, the Smart City Living Lab has been developed in IIIT Hyderabad with the help of like the project is supported by MIT and Smart City Mission of India. And what we have done is that, I mean, as you can see, it's a lot of there's a lot of nitty-gritties to it when you're trying to develop a smart city. You have to worry about the base layer, which can, for example, be sensors and actuators that are doing all the sensing. But then you have a communication layer which has to take all of that information and send it into what we call a data lake or some kind of a middleware platform where all the information is then stored as well as archived in a specific semantic manner so that it can be queried from the applications. So what ends up, this stack typically ends up being like having a dominant middle layer where where the middleware platform is sitting. You have different user agencies and applications trying to get information from the middleware, and that middleware is getting fed by the sensors and actuators from the bottom. So it becomes kind of a stack. And what we have done is we have basically taken what's called oneM2M as a middleware standard, which has now been adopted by Government of India as the de facto standard for smart city missions after our recommendations. So oneM2M is basically a platform that has been made out of a collaboration in between 8 different telecom agencies, including that of India's, US, Japan, Europe, and few more countries. So it's an open source standard, and we actually as IIIT as well as through TSDSI, which is the Telecom Authority of India, contribute very regularly to the oneM2M standard. So these are some of the nodes that we have deployed in IIIT. So coming to the paper at hand, what we did is one of the protocols that we wanted to try out or demonstrate or see is called Bison. It's a wireless communication protocol, and very recently developed. It's a mesh network. It's almost like how Sigfox works, but this is based on the modulation strategy is more based on Wi-Fi specification. So it's 8.2.11 protocol, and because of that, what ends up happening is that you can actually get a lot of compatibility between certain devices. Of course, the frequencies are different. In this case, we are talking about frequencies that are sub-gigahertz, so 865 to 868 megahertz, which is also used by some other protocols like LoRaWAN and such, because in India, it's an ISM band, so it's basically license-free band in India. So this paper basically focuses on, for example, can we make a street lighting system or a solution using Bison protocol? Now, there are several advantages to this. One of the reasons is we want to work with this is because Bison networks are self-healing. They're a mesh network. So what they end up doing is that they form so if you have various nodes that are basically spread out in the form of, say, street lights and across a city, they will basically connect to each other. And the way they work is that if one of those nodes is actually connected to the cloud, the information from all of those nodes can be sent to the cloud. So all of those nodes basically act as a hopping station, like a transceiver, and information is relayed from a specific node through that network to the cloud using one of the nodes that is connected to the cloud. That specific node is basically then called a border router. So for example, here you can see there is a border router, there is a backhaul to the cloud, and within this network, all the nodes that are connected to each other can, for example, this node that is very far away from this node doesn't have to worry about the fact that it's not in the range of that particular gateway node. It can still communicate seamlessly with the cloud. I mean, the entire hopping protocol is built into the stack of the Bison itself, and the formation of this mesh also takes place automatically once you have the SOC stack there. So, so like I said, we have a router node, which basically, for example, in this case, if you want to attach it to a street light, you can basically put a relay in it, have a transceiver node, and connect it in a mesh network, so that when information is relayed from the cloud to the node, the relay can switch on and switch off the light, or dim the light depending on what information has been relayed, right? So, for example, switching on and switching off or dimming the light can then be given as a command to a specific street light in the entire network. Now, there is, like I said, a border router, which in our case, we utilize Raspberry Pi to connect to make the border router. And in the case of nodes, we have basically just taken the radio module. Initially, so this radio module is, I mean, in this particular case is manufactured by Silicon Labs. They are the manufacturers of this SoC. Earlier, what we used to do is we used to take that SoC and then put like an Arduino board or something like that takes the commands and deals with the relay and dims the light and everything. But given that this SoC has a microcontroller in itself, you can actually do all of those operations without anything else. I mean, you can just take the module and connect to the relay, and it will do everything for you. So that router node can be made. Whereas the border router has more things to do. It has to connect to the cloud. It has to, I mean, for example, if you're using TCP/IP protocol to connect to the cloud, it has to have that Ethernet port, and the stack needs to be there for the communication. So in this case, we use the Raspberry Pi and this module, of course, the same one, because a Bison, it has to have obviously Bison connectivity. So that is how we made the border router. And like I said, we use oneM2M as a central server for connecting information. For example, when do you want to switch on the street light network or switch off the street light network? That can be done using oneM2M. The interesting thing is, because our oneM2M stack takes information from the entire IEEE Hyderabad campus, it actually also knows things like, for example, it's also connected to the weather station. That's the beauty of having this middleware, because that middleware knows everything about your campus. Okay, how much water you're consuming, how much energy you're consuming, what is the weather right now, what is the street light situation. So it can truly act as a smart system. And for example, in this case, we have tried connecting it to the weather station in the sense that if the luminosity of the sky is so and so, you should switch on the street lights, and if it's not, then you should switch off the street lights, instead of doing it manually or putting it on a time basis or something. We wanted it to be real time based on the weather conditions that are prevailing. So those kinds of things can be done if you're connected to the middleware network. So yeah, so this is the node that I was talking about. Not sure if the text is clear. But it has, for example, it has the module here. The wireless module is here, the Bison module. The antenna is here. We have, the relay module is basically here. We have the power module, because these street lights are on AC power supply. So if you want to power this thing, you have to basically convert it into a DC. So that conversion is there, and some more peripheral electronics is there. So we basically take this, put it on the the smart street lights that we have, and from there control everything through Bison. So the results are that we get this kind of a system inside our campus. So this is the map of the IIIT. We are hoping that we can expand this map into Hyderabad at some point in the future and different smart cities. But this is what a smart city should look like. All of these points that are being shown in blue and green are the street lights in IIIT. Okay, and they are all connected through Wi-Fi. And sitting at a dashboard, I can then switch on, switch off a bunch of them. I can automate it based on weather conditions or timing. In the future, we want to automate it based on whether people are walking there, like using a PIR sensor to sense whether a particular street is being used or not. It's a challenging problem in the real world because you have to worry about dust and pigeon poop and everything else. But we are still trying to see whether we can actually do that. But this one has already been deployed and it's already been working for the past 6 months. One of the reasons why we call our smart city living lab a living lab is because all of these demonstrations that we do are not inside a lab or a test setup that is there for street lighting or something. It's the actual campus that people are living in with 2,000 people using the same street lights. If anything goes wrong on the Wi-Fi network and the street lights switch off, I'll start getting phone calls from security and everybody else. So it's so that's why we call it the living lab. It's not a lab in the traditional sense. So whenever we do these experiments, you have to be very careful about what is possible and what is not possible in the real world. We do, of course, a lot of analytics on it. For that, I mean, you can read the paper. There is analytics on the distance between these two poles versus what the signal strength is that we are getting. Like RSSI values versus distance is a very important metric that we have to look at. We also look at how the mesh network is forming and reforming. For example, if one of those nodes decides to switch off or we're not able to communicate with it, the mesh network reforms itself. And so yeah, I'm just done, like 1 more minute. So yeah, so that is what we have. So like I said, it's street light integration, closed loop feedback. We can have manual override is built into the system as well. We have sunrise sunset controls. We have RSSI and latency being studied, for the network. And in the future, we want to, for example, use this as a test bed for other applications. One of the interesting things about putting Wi-Fi on street lights is that street lights are at a specific distance in every city. So if you make it a Wi-Fi network, it actually gives you all of those nodes are acting as a mesh network anyway. So they act as Wi-Fi routers. So if you have any other independent Wi-Fi node anywhere around these street lights, it will connect to the cloud automatically. So you could say that the entire IIIT Hyderabad campus is Wi-Fi enabled, meaning you can just roam around with a Wi-Fi node and it'll just connect to the cloud through one of the street lights. You don't even know which street light, but it'll take care of itself. So if you do that in a city, you can have a Wi-Fi enabled city and then you roam around with a Wi-Fi enabled device. It will just connect to the cloud directly. So this street light network not only controls street lights, it actually makes a backbone network for everything else. So yeah, that's all I had for today. Thanks.